Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Sunblock by Koktislav. And here are the rules. We have chaos construction rules, where we need to divide the grid into 9 regions, each consisting of 9 orthogonally connected cells, and regions do not overlap. And we need to place the digits 1 through 9 once each in every row, column, and region. So what is an orthogonally connected region? It would be basically a region where you can go from any cell in that region to any other cell in that region just by going through edges while staying within the region. So this is an example of a valid orthogonally connected region, because you can go from this cell to all of these cells by just going through edges while staying within the region. This would not be a valid orthogonally connected region, because even though these two cells can get to each other by going through edges while staying within the region, they can't get to any of the other cells in the region by going through edges while staying within the region. They would have to go through a corner or exit the region by going through an edge, and that's not allowed. So that's an example of how orthogonally connected regions work. We also have suns, where the digit in the sun counts how many of the up to 9 cells in the 3x3 square centered on that sun belong to the same region as the sun, including the sun cell itself. Example: if row 4, column 1 equals 3, then exactly 3 of the cells, row 3, column 1, row 3, column 2, row 4, column 1, row 4, column 2, row 5, column 1, row 5, column 2, belong to the same region as row 4, column 1. That is interesting. Huh. Okay. I'm thinking of the implications here. So basically, only 3 of the cells in this 3x3 box centered on each sun, if this was a 3, would be in the same region. So you could have these 3 be part of the same region, and these 3 not. Or it could be like 3, 3 here. Or you could have something along the lines of 3, 3 here, and this is a different part, not a part of the region. Or you could have something like this being these 3 part of the region, right? It could be a wide variety of things. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Well, we know that the digit in a sun can never be 1. And the reason why we know that is because in every region must be orthogonally connected. So the 1 is guaranteed to have 1 digit at least, or every sun is guaranteed to have at least 1 digit sharing in the 3x3 box, sharing the same region. Because otherwise, if it doesn't, then it's not going to be orthogonally connected to its region. And therefore, in row 2, where everything is a sun except for 1 digit, that means 1 has to be in the non-sun digit. That means the remaining digits here are 2 through 9. That's interesting. Obviously, these are... So basically, every sun has to have at least 2 in the sun. That's... So... These digits must be on the edges, can only be 2 through 6. Right? Because we only have 6 cells in the 3x3 box that's centered on it. There's nothing in the corner, so we don't have to worry about that. And the 9-cell region here must have a 6 in... Wait, how does that work? 9 cells. So if it's 9 cells in any of these cells, the problem is this would form a region, and then this would see only 6 cells in its region, and this would see only 6 cells in its region. So therefore 9 cannot be any of these numbers. 9 has to be here. So this is a region here. We'll mark that as dark, and therefore this sees 6 cells in its region. So this is done as a region. We'll mark this as orange. So this must see 3 cells because this has to go out this way to connect as orthogonally as a region. So that's 3. This cannot be 3 or 6 remaining here. We can't have 9 here. This sees at most 5 cells, and it cannot be 3 cells. So this is 2, 4, 5. You could have just 2. That is potentially possible. So one of these, interesting, one of these is going to have 8 cells in its region, and the other one's kind of have to have 7 cells in its region. Well, that accounts for all 15 cells here. Right? It can't be 8 and 7 in the same region. Well, maybe. Hold up. So if we have 8 cells in its region, it has to be something like that. Then the problem is the 8 cells in its region, I guess you could have 7 that way. That is possible. Huh. So what are the possibilities here is kind of the question, right? So where are 8 and 7? Obviously not here. You could have 8... You could have 8 by itself. Oh, this can't be 8 going this way. It would have to be 8 going... Ah, that's kind of a problem. 8, unless it's on the end, well, can't be on the end. Oh, it can't be... Where can 8 be is a question. 8 can't be here, and 7 can't be here, because this can't have... How does 8 work here? 8 can never have 6 cells that overlap with another one. It could be 7 cells, though. So you could have 8 going something like this, and then this is 7, or something along those lines. Or this is 7. Can you have 8 and 7 be opposite, non-same regions? It would have to be something like this and then this. But I don't think that works. That does not work, because then this would have to be 6, and this would have to be 6. So 8 and 7 have to overlap. They have to be part of the same region. Okay. Which means you'd have... Could you have something like that? I don't think so, right? So 8 and 7 have to overlap, which means this is 7 or 8 here. Because we tried to have 8 as a region here. I don't even, like, maybe you could try to have 8 as a region here, but that would force 6 to be there, so that doesn't work. So we're trying to have 8 and 7 be separate regions, and it just doesn't work because the problem is, yeah, you have to have extended open here. If you have 8 here, the problem is 7 can't be here as a different region. So 7 and 8 have to overlap. Therefore, it must be 6 as a whole. And then you have 1 on one side and 2 on the other side of the 3x3. Can you have... You could have 7 here. I guess you could have 5 there. So that sort of works both ways, right? Okay, so we know this is part of a region. So this is definitely part of a region. It has to have 3 in the same region as 7, but we don't know which one it is. Or 3 in the same region as 8. But we don't know which one that is. So say we try to have this as 8. If this is 8, that kind of works with this as 5. So that's fine. So it'd have 8, 7, 5, and this would have to be 4 and be part of the region. We have these suns also. That's interesting. Okay. So again, we're guaranteed this is part of the 7-8 shared region. We're going to have 1 here or 1 here. So this is guaranteed 3 cells, 4 cells guaranteed here. So this is at least 4. And it could be up to 6 because the can it be 6? It could be 6. It could be something like that, potentially. So this is 4, 5, and 6. So what happens if this is the section that's part of it? It could not close this off. This would have to be, obviously, a different region. So we'd have a different region there, guaranteed. One of these two is, so this would have to be there, at least. This would then be 4 or 5. So what we could not have then is both this be part of it and this be part of it. But what we could have is something like this. What happens if we do that? Then this would be 5. This would be 5, that would be 4, but this would also be 4, and that doesn't work. So what happens if we have this as pink? So this can never be 8, is the point, I guess. Because we try to have 8 here. and then this becomes 5. That makes this a 4. That would not work either because this would be 5 and this would be 5. So this can never be 8. We know that for certain. Can it be 7? We have gray here. And we try to have 7 here. This is 8. It cannot go here, it cannot go here, so it would have to go here. This would be 2 going out that way. This would see 4 cells. This would have to see 5 cells. So then this would have to see 6 cells. And that does work. And then this is a separate region. And that would see 4 cells. So this sees 5 cells. This sees 8. This sees 7. This sees 4. This sees 6. This sees 2. So that does work in that scenario. Well, I don't know if it works in this opposite scenario. It probably does. What happens if we try to have this as 8? If this is 8, then obviously both of these are shaded. So then this would be 5. This can't be 5 or 6. It would be 4. This would be 8. That's 7. So it would have to go gray here. One of these could be 4. That doesn't work. So this doesn't work because we need 2 and 4 here. If this is 4, it must necessarily include this, but then this is not going to have 2. If this is 2, then this must have 4, but that means it closes this off, and then this doesn't actually have 2. So this cannot be 8 either. So this can't be 8 either, which means this is 8. So this cannot have 4. Because 4 would require these. We necessarily have 8 of these cells are the same region. So this must have 5 or 6. Because this would be minimum here. So no 8 here. This has to be 5 or 6. Can we have the gray here? I think it should be the same either way. Right, so then this is 7. You have gray here. This would be light going out here. It would be 2. We have 2 here. It could be 2 here. It's 2 here or it's 2 here. Either way, this is 5. This is 4. And it could be 4 that way. Since this is 5, this would have to is part of the region. That means this must be 6. So that's interesting. That would be 6. This would be 4. And this would have to be 4 going this way, which does work. So either way, this is these two are part of the region. Interesting. So these are definitely part of the region no matter what. So let's try again. So if this is part of the region, it's basically this. If this is part of the region, so say it's 7 here, this would have to go 2 there. So this would be 4. So either way, this is 4. So we definitely have a 4 here. This is 5 or 7. Again, if we have 7 here, this is shaded. Cannot go shaded here, it must go shaded here. This must be 2. No 2 or 7 here. This is 4, 5. it cannot go here and here, because then this would be a 4-5 pair, and they would both see 4 shading. So this must be part of it, which means this is 5. That makes this 6, so then this must be those. And then this is 4. So I think those are shaded guaranteed also. So again, yeah, if it's, so these two are guaranteed shaded. So we know those two are guaranteed shaded. This is then 5, 7 as a pair. Therefore, this is always 6. This cannot be 5 here. This cannot be 5 here. It's 2 or 4. This sees only 4 cells in the 3x3, so that's 4. Remaining digits in this box are... So in this region, it sees at most 5. So it cannot be 2. Because it goes out either here or it goes out here. So then this is 3, cannot be 4, it's 3 or 5 here of cells that it sees. Remaining digits in the dark region, we have 2, 3, 5, 7, 8. This can't be just 2. So, because if it's just 2, it just stops there. And then these can't be, it can't be a full 9-cell region. Okay. This cell can be up to, so what are the remaining cells here? This can be only 2 through 5. And these could be 2 through 6, I guess. This can't be 3, 2, 4, 5, 6. Okay. Remaining cells here are up to 7. So it could be 2, 3, 5, 6, 7. Remaining cells here are up to 7. 2, 3, 5, 6, 7. No 6 here because of 6 in the column. Remaining digits in the gray region are 1, 2, 3, and 9. Okay. This is necessarily part of this region, so we'll mark that as, oops, I don't know what just happened there. Mark that as light. This can't be 2. It has to be at least 3. These two are part of the same region here, so we'll mark that as pink. And it must go out here, so that's pink. So this is either light or medium, and this is either light or pink. We do know there's a boundary here, there's a boundary here, and there's a boundary here. If this is 6, I guess part of the question is, can these ever be separate regions? They cover 8 shared cells. So they would have to add up to at most 8. I mean, possibly. So basically what I'm trying to do is with not have a 6 in one of these cells. So hmm. Hmm. I mean, you could still have, well, you can't have 6 and 2 because then they would be not part of the same region. I mean, so again, let's try that. Then neither of these can be 6. One of them can either of these be 2, really? I guess. Hmm. This is interesting. Remaining digits in row. What happens if this is 5? That is actually a good, interesting question. If this is 5, these are pink. This cannot be 5 here. No 5 here. Can these ever be 7? That's 5, 6, 7, 8, and 9. Yeah, I guess so. But that would force this to be 4, and that can't be 4. So this can't be 7. Can this be 7? 5, 6, so 5 here. 6, 7, 8, 9. That would force this not to be 7, because this would be 4 also. Can this be 6 then? For 5. This would then be 2 or 3. So this would have to be 3. So this would be 3, which means this couldn't be 3. Therefore, these would not be part of the pink region. So you could have 6 there. 1, 2, 3. Can you just have 2? You can't have just 2. Because you can't extend any further here. You can't extend, if this is 2, it can't even be 2. It's 6. So this would be 6. It would have to be all pink here. 1, 2, 3, 4, 5, 6, 7, 8. And then this would have to be 2 because you can't have 4 more here. So that would be 2. This would be 4. So this would not be medium. This would not be... How did I get light here? This is medium or pink. That seems okay. This can't be 3 or 4, so that would force this to be 5, which means all of these are light. So we have this is medium. That instance. So this would be 7, this would be 5. That seems okay. 1, 2, 3, 4, 5, 6, 7, 8. And then one of these would be 9. And would have to be 3, interestingly enough. Then one of these is pink. So that could work. Okay, well, I was hoping that wouldn't. These can't be light. They are medium as the other choice. But I'm curious what happens, though, in that instance. So say this is 5. That means these are pink. This is guaranteed not to be 7. And it cannot be 2. So this is 3 now. This can't be 7. It can't be 5. Can't be 2 or 3. So this is 6. That forces this to be 6 here. This has 3 cells in the 3 by 3 box that are the same region. So this must be that way. This must be 2. This must be not pink. So no dark, or no medium. This is light. This would then be 2. We have 7. This is 5. That's 4. This can't be 3 or 4. It's 5. Which has full light as a region. This can't be 5 or 4. Okay. We cannot go to the sun because that would be 3. So this would have to be pink that way. So this would be the boundary there. This seems fine so far. 1, 2, 3, and 9. This would be 5, so this cannot be 5. This would be 4. Okay. One of these would have to be 3. It would be light here or light here, and that would be 3 cells. So one of these would be 3, which means the light could not contain 3 anymore. It would have to be 1, 2, 6, 7, 8, 9. No 9 here, no 6 here. No 6 here. No 5 here. Remaining digits, this cannot be 4. This can no longer be 6, so this would have to be 2 or 3. This can no longer be 6, so this would also be 2 or 3. That's interesting. How does this work as a 2-3 pair? I guess it could go... No, that doesn't work. So say we have light going here. Okay, light definitely could not go to here in that case. So this would be... Because if this is 3, this is 2. That means this has to go down this way. But then this would be 3. But can't go this way. It must go down. Oh, I guess that could work? Huh. It would have to go around here, essentially. I guess it could, actually. No, it cannot. And the reason why we know it cannot is because it would be trying to go here. This would be done as a region. This can only have 3 cells in the 3x3 box centered on it, having in the same region. So this can't be part of the region. This has to be, cannot be this only has 4 cells potentially in its region and can't be 2 or 3, so it has to have all 4 cells in its region. So this would be 4. This already has 3 cells in its region, can't be 2 or 3, has at most 5, but it can't be 3, 4, 5, and that's the contradiction. So this cannot go this way. It would have to go here. So you'd have to have light here. This is 2, so this would be 3. This would be 2. So no more 2 here, here, and here. This sees only 2, so it goes that way. This is done as a region. This cannot be 3. it sees 2 or 4 here. If it's 4, it's all of these. If it's 2, it cannot go that way because then it would necessarily need to go that way. So this is guaranteed to be 2 that way, at least. This is 6 at most. So it cannot be 2, cannot be 5. It's 3, 4, or 6. Yeah, this is a long, convoluted way to try to basically disprove this. Can it be 3? No, it has to exit out. So this is at least 4 or 6. If it's 4, it would have to go out here, or maybe it could go... No, it can't go 3 and block this off. This... Okay, then the problem... Okay, if this were 2, this would have to go out here. This would have to go out here, and this would be 3, which doesn't work because of 3 in the row. So then this must be 4. That makes this 6. So this is all green. I guess it kind of works, right? This would not be 4. It would have to be 5, so that's green. This is at least 7. That could work. Cannot be 8. Oh, that's interesting. So it has to go 7, which means green has to go this way. This is looking like the solution, though. Interesting. So no 6 here, no 6 here. We have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is looking like a solution here. Okay. Let's then go down the other path, I guess. Or we could assume this is 4 instead. So try to make that 4, try to make that 2. So this is pink, no light here. This is done as a region. This is done as a region. 1, 2, 3, 9 here. If this is 4, then this doesn't work anymore, so this cannot be 5. Because obviously that would be 3, and this could no longer be 6, and then it doesn't match 2. So this has to be 3 then, which means these are separate regions. No more 2 here. So no 2 there. 3 eliminates 3 here. These can't be 3. Aha, and we have a contradiction. Where's 3 in the dark region? It's here. And where's 3 in the medium region? It also is here, which means that we have a duplicate in row 1. So we know this can't be 3. This actually does have to be 5 then. I guess that makes sense, right? We have a guaranteed 3 in the gray region in rows 1 and 3. We have a guaranteed 3 in the dark region in rows 1 and 3. So therefore, that eliminates 3 from the rest of rows 1 and 3, which makes that a 5. So if this is 5, then this does have to go this way. We've shown that this is at least 3. We tried to have 7 here. That doesn't work. Why doesn't that work again? 1, 2, 3, 4, 5, 6, 7, 8, 9. This would see 4 cells. That's why. So this cannot be 5. It cannot be 2 or 7. So therefore, this is 3. This has to be 2. So this is the answer solution. Okay, so that's... So then this must be 6. That shows all of that. So this is not pink. Pink has to go all the way here. It cannot go to the sun because it would be 3. So pink has to go there. So this is done as a region. Boundary, boundary, boundary. No light, no medium here. This is light. That means light has to be one of these, all of these 4. So this must go down here because we tried going that way. That doesn't work. This must be 3. Which makes that 2 because this can't be 6 anymore. So this is 2. That's red going down there. It has to get out to orthogonally connect. We tried going just 4. That doesn't work because then that would force this to be 3. So this must be 6 as a region. So this is, sorry, this is 4 and this is 6. This must go out this way to be not 4. So this is 5. This can't be 8, so this can't be green here. So this must be 7. And this is, oops, boundary here. This is boundary here. This must go green there. So that's going to be orthogonally connected to one of these. So this must be 3. We don't know which way. It could be this one, or this one. If it goes this way, it's 2. And that's not going to work because of 2 in the row. So this is boundary. If it goes this way, it would be 2. And we can't be because of, no, actually can't be. It would be 3, which can't be because of 3 here. So this must go this way. So that's done as a region. This must exit out this way. This is 3 or 4. So this is 5 here, which eliminates 5 here. That means 5 is one of those 2 cells. Remaining digits of column 1 are 1, 6, 7, 8, and 9. 6 cannot be either of these because we need 6 in the light region, and it has to be one of these 3. No 6 here because of 6 in the row. This is 7 cells, and this is 5 cells in the 3x3 box. This is 1, 2, 3, and 9. 3 cannot be here. Okay, remaining digits of the light region have to be 1, 2, 7, 8, 9. Okay. This sees 3 or 4. Remaining digits of column 2. 1, 2, 3, 7, 8, 9. And this can't be 3 or 7. Remaining digits of green region are 1, 2, 8, 9. No 2 or 9 here because of 2 or 9 in the column. This can't be 2 or 9 either. 3 eliminates 3 here, so that's 1, which eliminates 1 in the rest of the row and region. 1 eliminates 1 here, so it's 8, which eliminates 8 in the rest of the region. Remaining digits of column 4 are 4, 6, and 7. This can't be 6 because of 6 in the row. This could be 4, 6, 7. Remaining digits of column 3. We have 1, 2, 3, 4, 9. No 2 or 3 because of 2 or 3 in the region. Pink region is guaranteed to have an 8 here. So 1, 4, 7, 8, 9. No 4 or 7. So we have, where is 7 then in the pink region? It must be here. So this is 7, which eliminates 7 in the rest of the column. This is 4, 6 as a pair. Remaining digits of column 4. We don't have 4, 6, 7, or 8, so we have 1, 2, 3, 5, and 9. No 2 in the red region. No 2 in the red region. This can't be 5. It must be 4, which means this can't be 4. This can't be 7 because of 7 in the row. Where is 4 in the pink region? It must be here, which means this can't be 4. It's 3, which means this is a boundary here. So we're going to make that yellow. It has to get out. Red has to continue 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's guaranteed red there. So this is yellow. It has to be 4 because it can't be 6. So this is 4, which means this is yellow. This is 6. This 1, 2, 9 triplet sees all of this cell, so it cannot be 1, 2, 9 there. 8 eliminates 8 here. Where is the 8 in the pink region? It must be here. This can't be 8 or 9 because of 8 or 9 in the row. This is 4. No 4 here. Remaining digits of row 4 are 1, 2, 8, and 9. No 1 here because of 1 in the column. No 9 here because of 9 in the column. Um, 2, 3, and 9 all see this cell here. So this cannot be 2 or 9. It's 7 or 8. 3 eliminates 3 in the rest of the row and column. Where is 2 in the light region? It must be one of these two cells here, which eliminates 2 in the rest of the column. So no 2 here, no 2 here. Which means 2 has to be one of these two digits, which eliminates 2 in the rest of the row. So this must not be 1, 2, 3, or 4. It's 5 through 9. Cannot be 5 because one of these is 5. That means we're guaranteed a 2 here, so this can't be 2 here. So this kit must be 1, 7, 8, 9 here. Okay. This cannot see 3, cannot be 4. It can go up to 7 at most, so this has to be 5. Because of 3, 4, 6, 7 in the row and column. No 3 here because of 3 in the column. 5 here eliminates 5 here, so this is 3, which eliminates 3 in the rest of the column. We have a 1, 2, 9 triplet in column 4, which eliminates 1, 2, 9 in the rest of the column. This can't be 1 or 9, it's 5. Remaining digits in the red region are 1, 4, 7, 8, and 9. 4 cannot be here. Where's 4 in the red region? It must be here. So that's 4. 2 and 9 as a pair in the medium gray region eliminates 2 and 9 in the rest of the row and region. So no 9 here, no 9 here. This is 3, which eliminates 3 here. We have 6, 7, 8 as a triplet, which eliminates 6, 7, 8 in the rest of the row. So this is 3, 5 as a pair. This 2, 7, 8 triplet eliminates 2, 7, 8 in the rest of the row. So no 7, 8 here, no 7, 8 here. Okay, we are guaranteed a 2 is one of these two, but we don't know which. This can't be 2 because of 2 in the row. We have a 1, 9 pair in column 4, which eliminates 1 and 9 in the rest of the column. This can't be 9, so this is 2, which makes this 9, which makes that 1. No 1 or 9 2 there, so it's 2. 1 eliminates 1 from being here or here. Okay. Remaining digits in column 6 are 1, 2, 7, 8, 9. No 8 or 9 here. No 8 here. No 2 here. That's fine. Rest of row 7 is 1, 4, 8, 9. No 4 here, no 1 here because of 4 and 8, 1 in the row. No 9 here because of 9 in the row or column. That means this can't be 4 here because of 4 in the column. So where's the 4 in row 7? It must be there. This has 5 cells in it. Rest of row 9, 1, 2, 7, 8, 9. No 1 here. Remaining digits of row 6. We have 1, 2, 6, 7, 9. This obviously can't be 1. No 9 here. Remaining digits of row 5. 1, 2, 3, 5, 6, 7. No 1 here. No 3 here. Okay. Huh. Can this be a full 9? The answer is no. Because then you'd have this as a region. It would cut off orange from being a full region. So we have 2, 6, or 7 here. This has to be, can't be 2. It's 5 or 6 here. It cannot be 5 going this way. This is definitely part of blue then. So this is part of a region. It could do something like that. That is possible. It could do something like that. It could do so it just can't do this 5 or this 5. So it could be full 6, right? Remaining digits in row 8. We have 1, 5, 6, 7, 8, 9. Obviously, this can't be 1 because of 1 in the column. No 9 here because of 9 in the column. Do we have all 9 8 4s? We should, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so this must be the blue 4. Okay. Where is 3 left in row 5? Where's 3 in the blue region? It has to be one of these two. So 3 is one of those. That means blue has to go all the way up there. So if this is... Can it reach here without going through here? So the question is, can this be a non-blue? So say this is non-blue. Then we would have to have blue going here, blue connecting here at least. But then this would be 1, 2, 3, 4, 5, 6, 7. I guess that 8 and 9 could work. So what happens if blue is here? If blue is here, orange has to be here and here. 3, 4, 5, 6. Huh. Okay. So it's definitely 3. We definitely have to have blue go up there. This is 5. So yellow cannot go here and here. If yellow goes here, no, it could. It could go here and here if that's yellow. Hmm. Hmm. If this were blue, how would that work? It can't just be 2 here, right? Because the blue has to extend somewhere around this 3x3 area. Could this ever be 2 is kind of the question. I think the answer to that is no. Well, maybe yellow? It can't be orange because orange has to connect that way and that would not be 2. So maybe yellow if this is 2? How does that work? Blue would have to go out this way. The problem is then this would no longer have 4 would not be correct. So no, this can never be 2. Therefore, it's always 6 or oops. This is always 6 or 7. Ooh, that's interesting. So it's probably blue. If this were 6 as something else, does that even work? Six as orange. I mean, we're just trying to make something that somewhat works. 2, 3, 4, 5, 6, 7, 8, and 9. The answer is no. There's just not enough cells left for this, right? You have to have 5 surrounding here. You need the 2 here. So you have 5 here plus the 6, and then that would be, yeah, that would be, so this can't be orange. Can this be yellow? I think the answer is also no. If this is yellow, we have 4 here, and then another 6 around here. And so no, the answer is no. So this must be blue. So this has to be blue, which means 6 at least of these are blue. And then this can't be 6, it's 5. Can't have 7 because we already have 3 that's not part of it. So this must be 6. This must be 5. No 5 here. No 5 here. This can't be 6 anymore. No 6 here. We have a 2, 7, 8, 9 quadruplet in column 8, which eliminates 2, 7, 8, 9 in the rest of the column. Also, where 6, it has to be here. And so this can't be part of blue. It's necessarily part of yellow. We have 5 here. We cannot go here because if that were the case, then it doesn't go and extend any further because we have 5 cells in the yellow already there. So this would not be a full region, so yellow does have to go this way. These are not yellow. So these are blue or they are orange. Probably blue. 6 eliminates 6 here, no 6 here. 2, 7, 8, 9 means this can't be 2 or 7, it's 3 or 5. Yellow has to go out this way to extend. We have 1, 2, 3, 4, 5, 6, 7. This must be 8, and it's part of yellow, so that eliminates 9 from the rest of yellow, so this can't be 9. This is 1, 2, 7, 8 as a quadruplet in column 6, which eliminates 1, 2, 7, 8 in the rest of the column. This can't be 1, 7, or 8. It's 9. That eliminates 9 in the rest of the red region and the row. So where is 9 in column 1? It has to be in this cell here. So this is 9, which makes this 1. That eliminates 1 in the rest of the column. So where's 1 in row 9? It must be one of these two digits, which means this can't be 1. 9 eliminates 9 in the light region, so this is 2, 8 as a pair, which eliminates 2, 8 in the rest of the row. This can't be 2 or 8, it's 9. Where are 3 and 5 in row 5? Can't be here, can't be here, can't be here, so this must be also 3 or 5. Yellow is either here or here. 6 has to be surrounding the blue. And this would be extra 3 here. So blue can be either here or here. Blue can be around here. Therefore, this can't be blue. This must be orange. Orange can potentially go to here. And that's it. Okay. We have a guaranteed 9 in the orange. This is 1, 2, 3, 4, 5, 6. This counts 3 cells in the region. So this is 3, 5 as a pair. It can never be yellow. So where is yellow? It has to go here. This is yellow, which makes this not orange. That's blue. We don't have a 9 here. We didn't anyways. This 7, 8 cannot be in this cell here, so this must be corresponding to that. So this is 7, 8 there. If this were orange, it would have to be 5. But the problem is we'd have 4 already here with these 4 cells, so orange could not expand here, and then this would be 3, and it would be blocked from being there. So this cannot be 5 and orange. This must be 3 as a blue, which makes this 5 and orange. This sees 3 cells in these cells here. So only one of these is blue. So we have 1, 2, 3, 4, 5, 6, 7, 8 blue cells. Therefore, this must be blue here. So we have boundary here, boundary here, boundary here. Only one of these is blue. If we try to make this blue, that doesn't work. Actually, and we need 4 oranges here, so this must be orange anyways. 5 here, 3, with 5 eliminates 5 here, so that's 3 and 5 there. We have a guaranteed 2 in the blue here. So either this is blue or this is blue. We don't know which. This satisfies 6 here. This satisfies 3 here, 5 here. So let's make sure the suns are correct. 4 in the same region, that's correct. 4 in the same region, 5 in the same region, 8 in the same region, 7 in the same region, 2 in the same region, 6 in the same region, 9 in the same region, 3 in the same region, 6 in the same region, 4 in the same region, 5 in the same region, 5 in the same region, 6 in the same region, 3 in the same region, 4 in the same region, 3 in the same region, 3 in the same region, 4 in the same region, 5 in the same region, 6 in the same region, 2 in the same region, 6, 7 in the same region, 3 in the same region, 5 in the same region, 4 in the same region, 5 in the same region, 3 in the same region. So the suns are all done. So I just need to do irregular Sudoku then. Um, hmm. We have a guaranteed 1 in one of these two cells. We have a guaranteed 1 in one of these two cells, which eliminates 1 in the rest of the cells. We have a guaranteed 2 in one of these two cells. Hmm. Um, hmm. Um, hmm. We have a guaranteed 1 in the light cells in columns 1 2. We have a guaranteed 1 in the red cells in columns 1 and 2. That eliminates 1 from the remaining. Well, okay, this is 1 2 7 8, so therefore this is 9. Okay, well, there's that too. This is 1, this can't be 1, this is 8, this can't be 8, it's 9. 1 eliminates 1 here, so that's 9. So this cannot be 9 here, which means this is guaranteed to be a 1 here, which cannot be orange. So this is blue, which means this can't be blue, that's orange. So that's done as a region. 8 eliminates 8 in the rest of the blue cells. So this has to be 2 7 as a pair, which eliminates 7 here in the red cells. That makes this a 7, which eliminates 7 in the rest of the column. 7 eliminates 7 here, so this is 8. This can't be 7 or 8, it's 1, which eliminates 1 in the rest of the column. 2 and 7 as a pair, eliminate 2 7 here, so that's 8. There's no 8 here. 8 eliminates 8 here, so it's 2. This can't be 2 or 8, it's 7. This can't be 7 or 8, it's 2, which eliminates 2 here, so it's 7, 2, 7. This can't be 2 or 7, it's 6. 7 eliminates 7 here, so it's 2 and 7. 6 eliminates 6 here, so it's 1, which makes that a 2. That makes this 8, this 7. No 8 here, it's 6, which means this 1 eliminates 1 here, so it's 8 and 1. And this can't be 6 or 7, it's 8. And that's a solution. Yeah, sometimes I go down the actual correct path, and then when I find that this seems to be working very well, I tend to go down the other path to try to disprove that. I should have seen the 3 from the very beginnings about these. There's no place for 3 in these cells, and 3 had to be here, so therefore this couldn't be 3. I should have spotted that. That was kind of a small error. Whatever. What can you do? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.